I am no longer at Sentry, as many of you have figured out or been told or otherwise. Uh, and I want to talk about why, but before that, I want to talk about all of the things that I've accomplished on this 3.5 year journey and the things that I'm proud of as more of a celebration of what I did at Sentry before we talk about, well, the goofy parts. But anyway, let's jump into it. Okay, so in order to talk about this, we got to go all the way back to the beginning, which is in 2021, when I was working at Stripe at the time. And not to go into the full details again, but basically I was building out a Python infrastructure team at Stripe, and it was largely canned to work on Java infrastructure. And I wasn't too plussed about that, but I stuck around until I got my yearly vest. Coincidentally, around that time, I was reached out to by one of the co-founders of Sentry, who wanted to build out a developer experience team. And surprise, surprise, I'm kind of the best person to do that. And so I basically told him, give me a few months and I'll see what shakes out with Stripe. And ultimately, I'll probably come and build that at your company. And, I'm going to close tabs as we go, because otherwise I'm going to lose my mind. And ultimately, I guess I should also talk about, we got an outline. This is the most prep I've ever done for a video, so I'm so sorry / you're welcome. And so we're gonna go over all these things. I'm no longer at Sentry. I'm gonna talk about how I got to Sentry in the beginning, why it's the best place I've ever worked at, talk about building out the developer infrastructure team. I'm gonna talk about some of my non-technical accomplishments as well as my technical accomplishments. Finally, we're gonna talk about what happened and then what's next. So that's what we're gonna go through. All right, so we're on why Sentry was the best place I've ever worked at. And the first thing about Sentry that I think is really, really awesome is it's a product that I can care about. It is something that targets developers. It's something that I use, and it's something that I can explain and talk about to other developers, and they know what the heck I'm talking about. Like, Sentry is a big name in software, but at the same time, it's something that I can resonate with and contribute to. The core product is open source, or I guess technically source available if we want to be pedantic about Sentry's funky, weird license, but source available, open source. I'm not going to have that argument today. But the cool thing about this is that meant that I can largely work in public. I can stream on Twitch like I always do, but I can stream my work on Twitch. I can do that during work hours. And in a lot of cases that was encouraged. It was something that people wanted me to do to represent Sentry and represent real things that people worked on. And I thought that was really awesome too, because it gave me an opportunity to connect with my audience about things that I actually did at work. It also meant that I could, produce content about things that I learned at work, or things that I built at work, or, weird problems or pitfalls or mistakes or things that I screwed up at work. It was something that I could be public and transparent about, and I really, really enjoyed that. And being open source was really, really important to me. Another thing that was perfect about Sentry for me is it was a small company. I say small in that it was smaller than any of the other places that I had worked at, Yelp, Lyft, Stripe. I kept telling myself, I want to work at a smaller company. I want to be in a place where I can, leverage my influence. I can effect change. I can, not be a small cog in a giant machine. And relative to some of those, Sentry is a small company. In a lot of other ways, Sentry is not a small company. And in some ways, Sentry even operates as a large company with a small number of employees, but that happens from time to time anyway. And often, a lot of people will often ask me like, well, don't you want to work at a big company and make more money? And money's nice, but I think I value being able to actually feel important and build stuff that I know is making a big difference. And so being a small company was really important to that. Okay, cool. So next, going through this list pretty quickly, we're going to talk about building dev infra, or this is what I called the team that I wanted to build. I was brought in to build this, to make this team exist. There was some effort that had happened before, and some of the stuff that I'm going to talk about here might be a blueprint that you might be able to use to build a similar team at your company. Maybe you don't have an org that looks like this yet, but here's how I think about it and how I basically built it from the ground up, and I think ultimately accomplished my goal of building that team, doing what I was hired to do. And I guess the first part is there was some existing developer experience, developer productivity work that was being done at Sentry, primarily by 2 engineers. And although there was some work in place, this wasn't their primary focus. They were doing this in addition to their product work, sort of in an as needed realm. And this is pretty common for most small companies, so, up to 5, 10, 20, 50 engineers. Often the developer environment or CI or any of the tooling around that is just done as needed. As people need this particular tool, they'll build it out. They'll unblock themselves or unblock their teammates, and there isn't really a concerted effort to do this. And so building out this dev infra team was a way to do a concerted effort for that. Fortunately, in bootstrapping this team, I was able to steal one of those 2 engineers, Armin, who is still my good friend. Oops. Oh, I forgot to mention. Yes, I made lots of Sentry content. Armin, not Armin, the other Armin that worked at Sentry, but Armin with an E, which it's great because now that there's only one Armin at Sentry, you don't even have to say Armin with an E because there's only one. It's disambiguated. But Armin worked with me to build out dev infra from scratch and bootstrap that team into what it eventually became. The first decision of this team was to figure out the name, and obviously I've been throwing around dev infra a lot, but I want to talk about why I picked that. Some other companies pick lots of different names to represent this, whether it's developer experience, developer productivity, engineering effectiveness, release eng, like there's all sorts of different names that this team might be. But I decided on the name developer infrastructure. And the reason for this is I wanted to capture that foundational aspect of it being like a platform building block for making developers productive. It's not just experience. It's not just what people do. It's not just productivity. We're not just measuring, how quickly you deploy stuff. It's not just like effectiveness and like how much you get done. It's really tools, processes, and other parts. And so I wanted that name to capture that foundational aspect. I know it's not that important. I'm being weirdly passionate about the name, but it's something that I think about a lot, and I think this name captures it, at least in my opinion, to the best that I want to talk about. And so sought out to found this team and founded it on a sort of set of core principles and pillars. When I'm talking about core principles, these are like beliefs that go behind everything that we do, like things that we try and practice and stuff that we're moving. And when I talk about pillars, it's kind of areas of work. You might imagine dev infra, starting as a team, and as say, as organization scales from 100 engineers to 1,000 engineers, this team might scale from being a team to an organization, and you might imagine sub-teams managing each of these individual components or each of these individual pillars. Obviously, that didn't happen while I was at Sentry, but I've seen this happen at other organizations, and so I wanted to sort of think about the team in terms of this. Okay, but I've talked about these. Let's actually define what each of these mean and how I think about them. And this will be more important later, I promise, because you'll see these principles and pillars called out later. And so I think it's important to talk about them. All right, so the first is self-service. And the idea behind this is we should build things that make it possible for teams to do stuff without needing to deal with a privileged engineer. Basically, allow people to solve their own problems. Whether this is like standing up services, creating deployment pipelines, setting up Git repos, setting up CI, being able to approve and release things, being able to deploy. This idea of self-service, meaning like all I need is myself and maybe my peers if I need sign-off, but I can do everything myself. And I don't need some gatekeeper in order to get things done. And especially, I don't want dev infra to be a gatekeeper for people getting things done. I wanted people to be able to do it themselves. Now, of course, with self-service, being able to put things out there, you sort of need the flip side of that coin. And I actually think that these two principles fit really well together. You need to be able to create things, and then you need to own them. Being able to throw a service out into production and then someone else owns it doesn't really mesh nicely. You get this kind of like impedance mismatch of, I can throw code out there, someone else is responsible for it, but they don't have the knowledge or wherewithal or care to own it and make it successful. And so, with freedom comes responsibility, as I would often say. Next is a golden path. This was the idea that we should build tools and processes to steer people towards something that we can support. And ideally, that is the best experience that they could have. But at the same time, allow people to veer off of that into unsupported territory if they need to do something particularly special. But generally, people should stay on the golden path and end up in this supported realm where things work well and we have the bandwidth to support them inside those things. Next is one that, this is kind of just a personal goal in general, which is high quality. We should be building these as if, building these tools and processes as if it's a product. Don't ship garbage. I hold myself to what I feel like is an extremely high bar of quality on code coverage tests, type annotations, monitoring, etc. Build a quality product and, take pride in that thing being quality. In the same way that we want our developers to ship high quality code, we should be shipping high quality tools such that they can actually do that. And the last core principle, and there's obviously more principles, but I think these are the 5 that I tried to limit to 5. The last is dogfooding. That is, if we build a tool, we should be using that tool. If we build a process, we should be going through that process. We should be using our own things that we set up. And if you ask one of my coworkers, it's this actually just means we're eating dog food, but that's a different story. And ideally with dog fooding, not only should we be using our own tools, but we should be using the Sentry product in whatever way is possible. One example of this is we wanted to measure flaky tests. And I'll actually talk about this more later. We wanted to measure flaky tests, and you can kind of think of a flaky test or a failure in a flaky test as an error. And you can kind of think of an error as a crash. And so you might be able to package that up with Sentry SDK and then report it using Sentry. And so we sought out to hook those things together to get Sentry reporting on flaky tests. And so, it wasn't a traditional usage of the Sentry platform, but it was a way for us to use the product at the same time, derive value from some piece of infrastructure. Anyway, dogfooding. Okay, cool. Now let's talk about functional pillars. Again, these are kind of the ways that I would organize subteams if they ever became subteams. These are sort of focus areas and ways that we thought about the big blobs in our logical description of dev infra. And the first of those is developer environments. This is basically spinning up your own copy of Sentry on your laptop, being able to run tests, debugging, etc. Spin up any ancillary Docker containers that you need to do databases and stuff locally on your laptop, and make sure that all of that tooling works well, works well locally and nicely. Also linters, code formatters, that sort of stuff sort of fell into this category, and. Almost all of the complexity in developer environments, and really all the rest of these things too, comes from Sentry's repository setup. I mentioned before that it's largely open source. I closed the tab already, but oh no, I still have the tab. It's largely open source in this Git Sentry repository. There's another Git Sentry repository, which is the closed source sort of wrap around this. I like to call it 2 monoliths that are tightly coupled, which is often really difficult to maintain, but especially difficult to maintain in the developer environments, I guess. In CI as well. Deployment's a lot simpler, but most of the complexity that my team dealt with was really managing those 2 separate repositories and their tightly coupledness. And that reflected a lot in the developer environments. Okay, anyway, CI is sort of the next pillar. This is where we have test frameworks, GitHub Actions, any sort of continuous integration, testing, validation stuff. That also lived here. We also did things with monitoring flaky tests, assigning them to teams, automatically disabling flaky tests, all sorts of test infrastructure landed in this CI bucket here. Next is deployments. Basically get code from a pull request to prod. As my first manager at Lyft, hashtag PR to prod. That's what this deployment category is. This also meant that this also encapsulated things like building out deployment pipelines to do release management or getting a service deployed or setting that up. And later this was managing the actual web app and deployment system that did those deploys, as well as a viewer tool on top of it, because the CI system or the CD system we ended up picking was maybe not the best, although they all kind of suck in various ways. So I think we picked the least worst one. It just wasn't the best one, if that makes any sense. Also, later on in Dev Infra, we merged with a couple of teams. One of the teams that we merged with was the open source team. And so we ended up managing this, in my mind, as an entirely separate pillar. This was things like the open source distribution of Sentry. There's actually a whole, like, I'm breaking my tabs by doing this here. Oh, I meant self-hosted. There's an entirely separate release of Sentry, which you can run using Docker Compose, and there were some similarities between how the developer environments and production worked, and so we wanted to unify all of those things, and it naturally sort of aligned with Dev Infra, and so we ended up taking that on. There's also this other miscellaneous bucket. I don't think it's really fair to include this, but a lot of the stuff that I championed ended up falling into this. This is sort of just like glue code between these other pillars, or things that I personally had interest in. Adding tools and processes were needed, or this also was like dependency management, security management, a few other things sort of fell into here. A lot of this is just like unknown things that ended up being passion projects. And so maybe they don't actually fit with Dev Infra, but I'm gonna include it. So sweet. All right, cool. So this is Dev Infra, and kind of what I wanted to talk about here. So now we can move on to accomplishments. Yeah. And the first one we're going to talk about, I'm actually using a feature that I completely forgot about in my text editor, which is multiple files, and it wraps around. But I had to try and remember the keyboard shortcut because I rarely use this feature. Fortunately, it's in the README. But anyway, we're on to non-technical accomplishments here. And I think this is the one that I'm the worst at talking about, perhaps because I'm not particularly good at non-technical accomplishments, but I think there's some stuff that I think that feels significant to me, at least. And the first is that I successfully built out this Dev Infra team. I've spent all this time talking about all these principles and pillars and blah, blah, blah. I made this shit happen. I onboarded a manager, senior engineers, new grads, interns, etc. We built things in all of these pillars that made this team successful. We practiced these core principles. We made developers more productive. We reduced the amount of breakages in production. We gave people safe ways to deploy code. And I think this team was ultimately successful and accelerated Sentry in a way that had never been accelerated before. Except perhaps maybe, early startup where you YOLO stuff into prod. You could say that's the most productive time. But for the number of engineers, I think this is a success. Along with building out this Dev Infra team, I also managed merging two other teams into Dev Infra. The first of those was a team called Foundation, which previously managed deployment and release tooling for SDKs. This tooling also ended up being used for internal libraries, and we'll talk more about that later, since I think parts of that were important in accelerating people as developers as well. The other that got merged into Dev Infra, I already talked about, was the open source team, which managed Sentry's self-hosted instance or self-hosted distribution, as well as the OSPO open source program office. Something like that? I don't know. OSPO. I guess I never really thought about what the acronym is. But we also took on that work as well. Another non-technical accomplishment is piloting and championing on-call. Traditionally, Sentry was set up as a classic SRE organization, or at least that's how I think of it, where there's a group of SREs. They're the only ones that are on call. They're responsible for any breakage in the site, and they're supposed to just sort of figure it out and fix it. I think a classic SRE setup works well when everyone can keep every piece of code entirely in their head, like you're 5 engineers and 1 SRE or something like that, and like everyone knows everything about how everything works. But as an organization scales out, it's basically impossible for an SRE to understand the entire system and know how to react to a breakage there. And having been at many companies, I know that eventually you need to get to a place where teams are, owning the code that they have self-service created. And so I decided, Dev Infra is going to be, an example here. And so we were the first non-SRE team to hold the pager and take an on-call rotation. And this was, again, firmly pushing that ownership guiding principle. And I think it was actually really important for us to set an example here for the rest of the teams in the organization and say, like, hey, no, like if you set this up in a way that balances nicely how you do work and like what things can break and what things you can really respond to. This pager rotation can be a not painful thing, and essentially be a forcing function to increase quality and also at the same time like take responsibility for things that you ship. I also think that this on-call rotation was really helpful for us to feel the pain of our developers, like put the things that could fail into metrics and then alert on them and actually understand like, okay, if some deployment web API is unavailable, is that impacting developers? Do they care about that? If they do, sure, we'll put it in a metric and alert it on if that thing goes down. Or like if CI breaks on the primary branch, we should probably know. We're probably not the ones that broke it, but we can work to facilitate other teams to figure out what went wrong, or click the revert button if that's the correct action there. But I think being on call was a good example for the rest of the org. Another thing that happened was, or another thing that I did personally was affect a lot of change across Sentry through TSCs. TSC, Technical Steering Consortium? I don't know what the C stands for, but we're just gonna call it TSCs. This is basically Sentry's RFC process. What does RFC stand for? Man, I'm just acronyming all over the place. Basically the way that ideas were proposed and large pieces of functionality were changed. Sentry organized these into groups based on their focus areas. So like there was a front-end TSC, back-end TSC, Infra, and API, I believe was the other one. And I think there was a fifth one that got merged at some point. But I participated in all of these and was, often making pretty large changes to how Sentry did development and going through the process of working with each of these groups to, get feedback, have in some cases like early adopters, or understand whether this is something people wanted, and ultimately push a lot of the initiatives that Infra did and get quorum on these ideas. And talking to a lot of people in a lot of places is a lot of work, but was how Sentry did its decision making, and so I participated in a lot of those. Another thing that I did was I played a significant role in hiring Sentry's DevRel team, developer relations. I actually don't think this team exists anymore, but I helped get it off the ground at least, and helped them hire their initial engineers, and was able to leverage some of my, I don't want to say I'm a DevRel, but I know a little bit about influencer nonsense and like, producing content, and my YouTubes played a little bit of role in like how I can. Oh, did this tab die? No. Okay. My YouTube stuff helped play a role in being able to guide that and hopefully make it somewhat successful for Sentry. I don't know that it actually did or didn't, but it is what it is. Another thing that I did is I was the virtual track MC for the DEX conference. This was a developer experience conference that Sentry ran, and somewhere down here, I'm all the way at the bottom. I ran the remote track for this, basically the live stream and interacting with chat and doing talk handoff while the conference also happened in person. It was a little bit awkward. I'm not gonna lie. I was like, usually for streaming on YouTube, I'm just like, whatever, I'll just say what I say and make this work. This was a lot of work to like time everything, hand stuff up properly, not have dead air, also have things that were interesting to talk about, commentary about the talks, pay attention through all of it, manage chat. It was a lot of work, but it was kind of fun, and it was nice to be a face of Sentry in making this successful. Of course, I already had a microphone and streaming setup, so it made it kind of a natural thing to be there. And of course, I think the last thing that I was successful at from a non-technical perspective is I was an influential figure that got to show off a lot of technically interesting problems and solutions that happened at Sentry through YouTube videos and live streaming content of real stuff that I did. It's hard to measure that as something that's impactful, but I think that was like a big part of what I did at Sentry, was to be something someone could look at and be like, oh man, that's a cool thing that Anthony was working on at Sentry. That seems like a good place to work. That's kind of a neat solution. Anyway, Okay, now we're going to talk about technical accomplishments. This is the stuff that I think is more interesting, mostly because it's a technical YouTube channel, and talking about code and that sort of stuff I think is a lot more interesting. But yeah. From these technical accomplishments, most of what I generated here, or most of what I summarized here, I used this tool that I wrote called GH-Perf Review. I used to use this all the time when doing like performance reviews at work, basically to get an idea of like what work did I do over the last chunk of time. And it allows you to generate sort of this very rudimentary output that lets you summarize, oh, in 2022, I did 571 PRs across 47 repos, and here they are in chronological order. So I use this tool a lot, shameless plug for a tool that I wrote. Anyway, GH-Perf Review, kind of cool. First I want to talk about some silly stats, which is just flex some numbers a little bit. I managed to get this before I was cut off. I merged 3,524 PRs across the 3.5 years that I was at Sentry. The math for this actually works out almost perfectly in that, like, if you assume 50 work weeks a year, which like 52 plus holidays plus or minus, it's probably a little bit less than 50, but let's say it's 50 5-day work weeks, that's 250 days a year, 3.5 years, so about 1,000 merged PRs per year. That works out to 4 per day. I'm amazed at how nice this math is, but anyway, just a silly little number. But I think this, despite it being a silly number, I think it really, you look at my contribution graph on GitHub, and I closed it, but you look at my contribution graph on GitHub, and like it was something where I was pretty serious about getting shit done. And I like this stat. This also meant that, like, because I did so much work, I ended up being the number 6 contributor to Sentry of all time in the 3.5 short years that I worked there. I think that's pretty cool. I'm pretty proud of that. But anyway, silly stats. Yes. Okay. All right, technical accomplishments. These aren't strictly in order. I tried to roughly organize them in terms of these pillars here, but also some of them are out of order to tell a narrative. But there's a lot, unfortunately. So buckle up, and here we go. All right, first we're gonna talk about developer environments. And this is ordered in this particular way because I specifically ordered this because I wanted the first one to be first, because it was the first thing that I did when I was at Sentry. Now, you might imagine, like, I was tasked with coming in and building this dev infra organization. And in my mind, I sort of knew all of these things that go into building this team. Like I had these pillars in my mind coming in. I kind of had a feeling of how things should work in various ways, and like what stuff that people will eventually need, and like things that people don't even know they need up front. But I wanted to, one part of bootstrapping a successful team is you have to demonstrate it's valuable. And so I could have just come in and just started working on stuff and like changing things and moving stuff around. But that isn't what people actually want. What people want is to feel like you're building something that actually makes their lives better. And so at first, I just observed. I didn't try and change anything drastically. I listened to people's problems. I watched what people were asking for help with, and then figured out what was the most painful or things that were most surprising. And I did development myself. I worked on the same repo, and I figured out what was painful to me. And then I tried to fix those problems. And by far, man, there used to be like, almost 5 or 10 complaints a day in work Slack about this particular thing, which was dependency management on macOS. Stripe starts with an S. Places that I worked. Sentry is written in Python, and all the development was done on macOS laptops. At the time, it was mostly Intel, with newer people getting ARM laptops. And let me tell you, the ARM laptops initially were a huge pain, partially because Python dependencies weren't compiling pre-built wheels for Python or for packages on ARM. And so a lot of stuff had to be built from source. And building from source generally means you have to have a working C compiler, you have to have the necessary headers, you have to have brew in a nice state, you have to have the right phase of the moon, you have to, have sprinkled salt in a particular way, set up your sometimes it felt like divination in order to get a proper working environment. And this was evident almost immediately joining Sentry and seeing people's complaints about getting their development environments working. And this was almost entirely categorized into two things. One was building Python from source. We used PyEnv at the time, which I have a whole rant on PyEnv that I still haven't uploaded to YouTube, but maybe that'll happen someday, about how building Python from source is really, really difficult, and PyEnv doesn't really do much to help you. And so dealing with all of those on a Mac is also a pain. But the other big one was building third-party dependencies. And let me tell you, there was one that was so much worse than all of the other one, and that is Confluent Kafka. This package, my goodness, I'm not going to be able to find it here. But that package by far was the most painful of any of the packages we had to build, because not only did you need to have a third-party library installed, you needed some weird patch to it, you needed to set a bunch of environment variables, and you need to run it in a particular order. It was just a big pain in the butt. And I have encountered both of these problems before. This is the great part about having experience in this realm. This is actually the same problem that I solved at Stripe, and the same problem that I solved at Lyft, and the same problem that I solved at Yelp. Surprise, surprise, I solved this problem over and over. And the easiest solution for this is to, one, pre-build your Pythons, get them from some place that either you've compiled them or someone else has compiled them, you unzip them, and you have a nice distribution there. And then the other is to precompile your dependencies. And the typical way to do that is with a PyPI server. So this is actually Sentry's PyPI, internal PyPI. I say internal, but it's public because Sentry's open source. So the dependencies are also open source. And so anything here, there's no internal code here. This is all mirrored or built from public PyPI. But this is Sentry's PyPI. And so you can see here, we took Confluent Kafka and built it for all of the platforms and architectures that we supported, which was macOS and Linux, and x86 and ARM64, and for all of the Python versions that we supported. Which at the time of recording, I believe this is Python 3.11 plus, and didn't bother building for older ones. Although if you go back to the beginning, we initially were targeting Python 3.8. Actually, there's a funny, weird story about Confluent Kafka where they actually pre-built wheels for all of these various platforms, but then we're like, well, if you donate enough money to us, then we'll give you the actual files for this. And I was just like, well, screw that. I'll build them myself and host them here, and anyone can use them if they want. But they ended up eventually uploading them to PyPI, so I think things came around. But I don't know if they ever did Linux ARM64, but it doesn't matter. Anyway, pre-built all the packages, and overnight, this flurry of Slack messages of having trouble with dependencies vanished. It completely eliminated this entire class of problems by building out this PyPI infrastructure. The really cool thing about this is it actually uses the same solution that Chris and I built at Yelp called Dumb PyPI. And my favorite part about Dumb PyPI, I could talk about this for hours, is that it is entirely static files. The idea is you take an input list of package file names, it generates you a tree of HTML and JSON, and you can upload that to S3 or GCS or whatever, and put a load balancer in front of it, and you don't need any sort of web serving technology. You can just serve it straight from static files, which is super powerful. Like this entire website here, it's like instantly loads because it's just serving static files, which is so cool. Whereas a lot of the other PyPI solutions involve running this giant Java server, or I think Warehouse has 16 Docker containers to run for PyPI. But anyway, build this out, and I think it was really cool that I was able to leverage some technology that Chris and I built in the past, which is really cool. I also put a bunch of infrastructure around this to actually do the package building, which is this repo here, Git Sentry PyPI. Basically, it's a list of allow list of packages, the versions that they would build for, and in sometimes special build instructions. So for packages that need, particular libraries from Brew or from apt, you would install those. Some packages need very complicated build setups, including our friend Confluent Kafka here. But I built all the infrastructure on this to basically give people an easy way to opt in packages and get them into a PyPI. And going back to, again, core principles of self-service here, this was another situation where if somebody needed a package, it was self-service. So anyone in the engineering team could approve a pull request, and so you could self-service get your library out there, which was pretty cool. I talked about ARM64. This also meant that, among other things, that we had to build out CI infrastructure to run on ARM. This was in an era before GitHub Actions had support for ARM, so we actually used a different CI provider called Cirrus, which was one of the few providing free ARM at the time, and had a bunch of infrastructure about managing that. Fortunately, we no longer need to do that, or I guess we. Sentry no longer needs to do that because ARM64 is supported natively on GitHub Actions now, which is pretty cool. In order to get Sentry to actually use this, though, we needed to actually get packages that built, and this often meant upgrading a bunch of stuff. I think I ended up upgrading probably 10 or 20 packages in order to get there, and then eventually, a small change to actually use internal PyPI. Delete a bunch of code and speed up some stuff. A lot of red is good. But delivered immediate impact, 30 to 40 seconds on every CI run. Removed a bunch of M1 hacks, allowed people to actually run the dev tools on M1s. And I guess the term M1 is silly now because it's just a Mac laptop, because they don't even sell Intel ones anymore. But this was, one big chunk of work. That was something that I just noticed immediately when joining and seeing people's complaints. Related to this, we also froze dependencies. Before this, we were just installing floating transitive dependencies. So if a supply chain attack happened on some dependency that Sentry was using, it would just instantly get installed. And we moved to frozen dependencies, where we were basically locking every single version that we were using, and having a reproducible virtual env, which was really important there. Okay, let's move on to something else. And this is actually going to harken back to why developer environments were difficult, which is we attempted to merge the open sourced and closed source repositories. And I mentioned this under the technical accomplishments, but really this was largely a non-technical accomplishment. This was something where I knew this was a constant source of pain point for developers. It was, probably about 80 or 90% of the complexity in each of these pillars of the dev infra, code and tools and processes around stuff. And I knew this was a problem, and I wanted to figure out why we had this closed source repository and ultimately eliminate it. And when I looked at this, the code in the closed source repository was mostly two things. Or three things. One, code that didn't need to be closed source but was closed source out of either convenience or accidents. Two, production configuration for how Sentry runs in prod. Obviously that needs to stay closed source. And the third was the billing components of Sentry, how Sentry charges for things. And when talking to all of the directors of product teams at Sentry and leaders throughout the organization, it became pretty clear to me that even though this billing code existed, if somebody had access to it, it really wouldn't change much about Sentry. If I wanted to sell Sentry illegally, because Sentry's license prevents you from reselling, the current copy of Sentry due to the way their funky license works. If I actually wanted to illegally sell Sentry, I would just slap Stripe in front of it and call it a day. I would in no way try and use Sentry's complicated billing system that solves problems for Sentry that no one else would really want or need. And this was essentially what I had convinced everyone else at the company. It was like, hey, we have this big ball of complexity that makes it really hard for people to roll out changes. It makes it really hard for us to improve all of the tools around how people develop. Let's open source it all and do the work to get rid of all the things in the closed source repository such that we can make this happen. And ultimately we didn't finish this, but we did manage to open source the front end before the project was unceremoniously and forcibly canceled right before we would have done the back end as well. But you can't win them all, unfortunately. So let's move on to something else. And actually, we're going to move on to a different pillar. And this is the one where I think I have a lot of smaller things, but also a lot of things that I feel like are really impactful, which is CI. There, of course, are other things in developer environments, like we built a set of unified tooling. We built some stuff that made it really easy to bootstrap a developer environment from nothing. We built a tool to manage services in Docker containers using a wrapper around Docker Compose that unified our self-hosted and development environments and a bunch of other stuff. But I want to talk about stuff that I was more personally involved in. So let's move on to CI. And the first of these is CI speed improvements. And let me tell you, if there's one true fact about CI in an actively developed repository, is that the tests always get slower. Over time, you would hope it's linear, but sometimes it's super linear, and Sentry was no exception to this rule. The tests were always constantly getting slower and slower, and at least 4 times while I was at Sentry, at least, it was probably like 5 or 6 more, I did some major effort to reduce CI time by at least 50%. I think at the worst it was at like 40 minutes per CI run, and at least 3 times I sent out a company-wide email that was like, oh, we reduced CI time down to 20 minutes or down to 15 minutes or down to 12 minutes, and would find some low-hanging fruit or moderately low-hanging fruit in order to improve that. But eventually we sort of ran out of these obvious big wins. And the last one of these, which actually is less of a technical win and more of a people win, again, I guess I could have categorized this better. I was able to double our shard count, but this actually, the change here seems obvious. Like, oh yeah, we went from 11 shards to 22 shards. Obviously, it's faster now. But the actual work into getting this to happen involved negotiation with GitHub. Because prior to this, Sentry was limited to just the normal open source limits of a repository, and I worked with our representative at GitHub to get them to change the number in the database such that we could use more instances. Convince them that, like, 1, Sentry paid them a bunch of money, but 2, also like GitHub uses Sentry. Like, Sentry is like kind of a universally useful product that happens to be hosted on GitHub, and if we had more GitHub Actions workers, that would make everything better. With 11 workers, we were continually running into queuing issues where we would queue behind ourselves, and like if you added a 12th worker here, like it wouldn't be faster. It would be almost 20 minutes slower than doing 11 workers because one of them would queue behind the other. And so eventually we got them to change our parallel limit and our account parallel limit to allow us to do this. But also, even with that, even with just this change being that simple, it was not that simple. By resharding the test, this meant that tests ran in different buckets suddenly. And so a lot of tests, what is this generate unit test button? I don't want to know. Generally, when you reshuffle tests in something that had always run in a very deterministic order before then, you're going to run into a lot of test failures. And so I had to go through and fix a bunch of tests that, ended up like some global was written in another place, and like 2 tests run in a particular order would cause a failure. Fixed test pollution caused by global mocks. I guess here's maybe an example. Where is this? Oh yeah, so like these are actually global variables because they're class members, and so if they get modified by one test, they'll also show up in other tests. So I'm basically finding a bunch of errors like this and eliminating those errors there. So it wasn't as simple as just number get bigger. There was a lot of other work in this. And actually, this is sort of a pattern in a lot of the things that I'm going to talk about today, where it's like I had this one big change that delivered a lot of impact, but there was actually a lot of smaller changes that got split out beforehand in order to culminate in this, this eventual impact. All of these things on their own made small improvements, but ultimately the big win was after all those small things had been done, the large thing could deliver the overall win. And I guess I skipped over it earlier in like the PyPI thing. I needed to update 15 different libraries in order to get them to build properly for each of the architectures and platforms that I wanted to support. And so I needed to upgrade those in Sentry, so we didn't need to build old things. And so I had to upgrade a bunch of packages. Anyway, I guess on the same topic of like CI speed, there's another aspect of CI which is often pretty difficult, which is test flakiness. As you add more tests, they tend to have, even if you have a 0.1% flake in 100 tests, you're almost always going to hit that. And so trying to collect data on that and then assign them to teams, automatically disable tests, fix tests, etc. There's a lot of work that goes into that. And we actually went about doing this, and then some of this actually happened before I joined Sentry, but I worked on getting it integrated and making sure that this was actually data that we cared about and actioned on. This is a PyTest plugin called PyTest Sentry, and it does, dog fooding of Sentry. It takes PyTest failures and ingests them into Sentry as error transactions so that you can figure out what your flakiest tests are, which I think is really cool. It actually has some problems though, and we eventually replaced this with a different system that unfortunately I think is closed source. Like it doesn't report some test failures at the end of a run due to weirdness, but whatever. But this allowed us to figure out like what were our flakiest tests and how could we assign them to teams and get people to tackle them and work on them. I also used a tool that I wrote pretty often to solve tests, both in like the, test global thing, but also in flaky tests here, a tool that I wrote called Detect Test Pollution. This is just a shameless plug. I wrote this before I was at Sentry, but this is a really cool tool. I have several YouTube videos on it if you haven't seen this yet, but it was also very helpful at Sentry and I used it quite a lot. We also set up this test shuffler, which allowed us to kind of preemptively find these flakes before developers found them, either through their CI runs or through running tests locally. That worked by deterministically shuffling tests based on a seed that we would run weekly and collect sort of test failures on this. And so this is some of the infrastructure that we went into, quantify, assign, and fix, and find flaky tests. And I think this was, I actually really like this test shuffler because it was kind of an interesting thing to set up. Unfortunately, we never actually hooked up the monitoring to it, but the eventual idea was to take the output of the test shuffler and feed it into a system that would assign those issues and disable tests automatically. We did actually build a separate system that automatically disabled flaky tests. Unfortunately, it's closed source, so I can't really show you that. It's sad. Okay. Another aspect of CI, this one's actually, I think, kind of an interesting one because I have a YouTube video specifically on this topic on GitHub Actions vulnerabilities. And this is a really old video. This is a San Mateo era video. And actually, wait, I'm pretty sure I reported this. Yeah. I'm pretty sure I reported this to Sentry. Oh yeah, here it is. Before I worked at Sentry in November of 2020, I reported the same vulnerability to Sentry at the time. But basically this was, a pull request target. I'm not going to go into the details of the actual vulnerability, but this was something that I had to go through a bunch of work in order to make it so that people couldn't exfiltrate all of the secrets of the closed source repository just by opening a pull request. And like very carefully crafting this such that people needed a particular tag and also make it work automatically for internal employees and blah, blah, blah. If you want to understand the actual vulnerability, this video goes into more of the details. But basically, there's a way to do arbitrary code execution just by opening a pull request if you're in a privileged context that also runs arbitrary commands. But anyway, just one of the things that I fixed at Sentry. This was something that I just noticed and was like, okay, I know this problem. I've talked about it publicly before. I'm going to just go through and fix this for Sentry because I, see something, say something, fix something, basically. Another thing that I did was eliminate a dependence on Docker Hub. Sentry spins up a bunch of containers in order to validate the actual app, and these might be databases or memcached or other stuff like that. And Sentry was using, I think, 3 or 4 different Docker registries at some point. And the more single points of failure you have, the more likely things break. And so we tried to instead put all of our eggs into one basket, which was to move any of our Docker images to come from GitHub's container registry rather than Docker Hub. Also, Docker Hub at some point added pull limits, so you couldn't pull from them in CI because everything would break. And so I built this system to mirror images. This actually, I built this entire thing on stream, which I think is cool. And it was during Hack Week at Sentry. And so I think it was, it was kind of a successful hackathon project. I managed to eliminate an entire failure mode just by moving where we get where we get Docker images from. I also managed to make a cool YouTube video about this, about how the Docker registry API works. And so if you want to understand more of the nitty gritty of how I built that thing, I actually made this video, the Docker registry API. Ooh, what a haircut in that video. But again, this was another example of like, I built a cool thing at work. I was able to talk about publicly exactly what I did and how I did it. And I actually was able to build the whole thing on stream at the same time, which, I don't know, cool product. I was really, really happy with building this thing. On to the next thing, which is test frameworks. When I joined Sentry, there were actually 4 or 5 different Python test frameworks. This is just an example of eliminating one of them. But ultimately, everything should be PyTest, and so we're able to factor these out. This one in particular was not great because it was pulling in the deprecated mock library, but also it didn't support Python 3.9, I think it was, and so 3.10 or I don't know, some version of Python, this abandonware library was never going to work for, and so this was just one of the many things that I eliminated along the way. There was also a framework called Before After, and I didn't write down the third one that I got rid of, but trust, there were other ones. Another test framework that I moved was from FreezeGun to Time Machine. FreezeGun kind of being the, I don't know if it's deprecated or just like not super well maintained or like slow or something. I don't remember the exact details. And unfortunately, the context is stuck in the private repo. So womp womp. But I moved from FreezeGun to Time Machine and built, a migration layer that allowed it to seamlessly work the same as before. Just, use this helper instead of this helper, and everything should be the same but better. I think that's kind of a nice, maybe I should get that on a t-shirt. The same but better, which is a lot of just refactoring and dev for work in general. But anyway, test frameworks going away. Okay, next, and this is again another technical win, but was really more of a people problem than an actual technical win, which was visual snapshots. This was a CI system that had been set up to do pixel by pixel diffing, looking for regressions in front-end rendering. Basically, there were 2 ways to generate snapshots. One was JavaScript tests that spit out JSX Markdown, or Selenium tests that interacted with the browser and took screenshots. And there was this whole system that would upload gigabytes of images per pull request and compare them pixel by pixel. And if any pixel was different, you failed visual snapshots. In theory, this was meant to identify regressions. But from a developer survey that we did, it was the #1 complaint at the time of, this is getting in my way and wasting my time. This is something that people were constantly retrying, spending a lot of time waiting for it to finish, and it was almost always flaky. But in order to actually get rid of it, I needed to convince the stakeholders of the people that built this and the people that were using this that it wasn't useful, and that their eng leaders should also be on board of getting rid of it. And that was the harder part. And so again, as I talked about before, I went to all of these TSCs and proposed, hey, we want to delete this thing. We think it's impeding developers, where we don't think it's actually providing value. What do you think of this? Just initially, just like, what think? Is this okay? And that didn't work so well. I needed a good way to demonstrate with data that this was actually harming people's productivity. And so I sought out to find a way to do that. And what I ended up settling on was surveying every single pull request in a period and figuring out, did it pass or did it fail? If it failed, why did it fail? Was it because of someone else's branch? Was it because of an actual failure? Was it because of a flaky test, etc.? And categorize each of them. Unfortunately, I don't have the screenshots of the spreadsheet that I put together, but it was super good. I looked at, I think, 250 pull requests and categorized each of them. I had pie charts for all the failure modes. I do remember some of the stats though, which is over 50% of pull requests had some sort of visual snapshot failure. So it meant that if you created any branch, you kind of had a 50-50 on whether this would fail and whether you had to put in additional work to either triage the pixel differences or rerun it. When I looked at the actual failures and categorized them, less than 1% of failures were actual real regressions. And none of them resulted in people fixing things. They were all ignored, and one of them actually broke production. And so this entire system that was meant to stop people from breaking production ended up failing to do the one thing it was designed to do, for better or worse. And I thought this was pretty compelling data. I took this to all of the engineering leaders. And once I had this concrete data that was like, here's the time that people are wasting, it was a much easier sell on saying we should get rid of this system. And I think the irony of this was one of the strongest opponents to removing the system that wanted to keep visual snapshots. They were one of the people that ignored a failure that went to production. So I think that was the nail in the coffin on visual snapshots, where they were like, oh yeah, I screwed this up too. This system clearly isn't working. It was, a classic case of boy who cried wolf, or visual snapshots that called pixel diff, I guess. And so ultimately was able to eliminate this and speed up CI as a result of this, eliminated a whole bunch of infrastructure that we were maintaining or trying to keep hobbling along, and reduced a bunch of cost, because this system was actually pretty expensive to run. Uploading gigabytes and gigabytes of snapshots to GCS buckets repeatedly is not cheap. But a whole bunch of work went into this, and I'm proud of the result. Okay, on to something different, which is fast revert. One thing about production breakages is you want to usually work very, very quickly to fix them. You don't want prod to remain broken. So usually that involves rolling back the change in production, using your deploy system to deploy the previous change. But you also want to get the bad change out of your source code repository so that you can start doing other things, deploying code that does work. And previous to this fast revert thing, we had, you would do a manual revert. You would create a pull request which undid the original change. You would sit through CI, wait for that to merge, then sit through CI again so that it could deploy, which is a big waste of time. Like, you want to be able to unlock things and get things moving again. And so I created this fast revert thing. And again, I guess this is the theme of all of these technical things that are actually not technical, because the code for this is simple. It's really just like get revert, get push. The actual hard part about this was getting this through compliance and making sure that this was something that our auditors understood was not actually violating our agreements there, and undoing code. Because technically, you make a change, some change happens on top of it, and you revert the first change. You're actually deploying a set of code that's different from the original code before the code. And so it's not technically, splitting hairs a little bit. Fast revert introduces different code that wasn't technically vetted. And so I worked with the compliance team to make sure that this was something that they understood the technical aspect of it and could defend the reason for this existing. Meanwhile, this has been used, I think, thousands of times now, and was like really, really effective in getting breakages to the site, reverted quickly such that people could continue on with their day and deploy stuff. But again, technical part really small, actual impact pretty big, and the hard part was convincing the people that needed to be convinced that this was, compliant with our source code policies. And one last thing that I wanted to mention related to CI, and this will actually come up later, is getting Sentry to be warning clean. This kind of has two main goals here. One is if you have a bunch of noise in your test output, you're going to ignore it 100% of the time. Log lines, warning, print statements, all that gunk just means you're just going to ignore if an actual warning occurs. And so through a bunch of changes, I managed to eliminate all of the existing deprecation warnings in Sentry and then enable the warning filter such that it doesn't regress. And this, on the surface doesn't sound that great. Okay, you have warnings and we fix them. But what this really unlocks is it means that if a warning happens, it's actionable. It's something that you fix eagerly rather than waiting for it to be a problem when you actually go to upgrade something, or when you, change a dependency or upgrade the version of Python. This was something where you could find things that are going to change, and in theory, later on, your upgrade is a lot smoother. And from upgrading lots of stuff at Sentry, this paid dividends very, very quickly. This was something that made a pretty big deal in making it easy for us to upgrade stuff. But as you can see, I had to do a bunch of separate work to make this successful and rebase this branch a million times until I actually got it working. But warning clean. Yeah. Cool. Okay. Next, we're going to talk about another pillar. Man, we've gotten through the first two. I promise the last few are a little bit shorter. In fact, we're going to skip this one entirely because I don't have much to talk about there. Let's talk about deploys. So it may sound crazy, but the way Sentry used to deploy was with this internal tool called Freight. And without going into details here, what Freight essentially was a web app where you pasted a SHA in a text box, you clicked a button, and it immediately deployed your code to everywhere all at once, all at the same time. This meant a couple of things. One of them being if your code change was bad, I guess the worst of it being, if your code change was bad, it immediately would bring the site down, like within minutes. If your SHA was wrong or somebody had already deployed a newer SHA, you would sometimes just silently roll back other people's changes. This, of course, got fixed through Warren if you rolled stuff back, but initially it would just, go live with whatever changes you had in that SHA. And there's not that much visibility in a SHA. Of course, that got improved in Freight over time. But ultimately, the biggest problem here was that this system was very opaque. It was not a deploy pipeline. It was sort of just a monolithic task that happened at a particular SHA. And it failed some of the core principles, especially self-service. If somebody wanted to add a service to this system, they would have to ask the SRE to manually edit some JSON in a database that would add them to this system. And so it was really difficult to add a new service. And, the way it deployed was 0 to 100 almost instantly, which meant if you had a bad code change, it would get reflected everywhere all at once. And so we moved from this system. Oh, also it was manual deployments entirely. There was no there was an auto deploy, but nothing really used it. Almost all deployments were manual, and so there was no continuous in CD, continuous deployment. There was no C, it was just D. And so we wanted to kind of accomplish all of these things at once, give people a self-service way to make pipelines, have a safer way to do rollouts, have them be continuous, and also monitor deployments in a way that was automatic, such that we had more safe deployments. And so we accomplished sort of all of these things at the same time. Actually, what is my next tab here? Yeah, we'll talk about canary deployments as well. We sort of accomplished all of these things by changing the deploy system from this thing called Freight to an open source off-the-shelf tool called GoCD. And now I think GoCD probably wasn't the best tool for this. They're all various states of okay, but we picked GoCD since it had the features that we needed, and we felt confident that we could build the features around it in order to accomplish whatever we wanted. And we did eventually build an entire visualization tool on top of GoCD to better represent how a change set goes out. But this satisfied basically all of those checkboxes that we had. We wanted people to be able to make their own pipelines. We wanted to make the defaults, the golden path of deployments be continuous deployment. We introduced the idea of canary deployments. I have another video which goes over the details of those, so you can search for that yourself. And we wanted to use Sentry to monitor deployments as they go out. Because prior to this, all monitoring of deployments was just people manually doing it or seeing if the site went down. And so what we did is we set up automated systems to check hey, we have this new code release. Does this new code release have errors? If it has errors, let's roll back. Just do that automatically. Don't roll forward things that introduce new problems. And so this would greatly improve the time to recovery if a bad change did happen to go out. Whereas it might be hours or days in the previous system where you wouldn't notice a change, breaking stuff. And again, this pipeline system was entirely self-service. You would put a set of YAML files in your repo and you would get a deploy pipeline. You wouldn't need a privileged SRE to twiddle a database in order to get things working. And again, like all the things before this, yes, a lot of technical things went into replacing Freight, but the bigger part of this was the people side of this. Continuous deployment was a completely new concept to Sentry. The idea of a canary deployment, yes, it slows down a deployment versus going from 0 to 100. But it was a lot of like deciding the trade-offs between, hey, we want Sentry to stop going down once a week or once a day or twice a day. We want to be able to have more confidence in the code changes that we make, that they're actually correct and don't introduce new errors. If they introduce new errors, we want to see those. We want to, understand things. We want to make rolling back something that we actually understand and can do more regularly and more often or automatically. And we wanted, security fixes to actually roll out. We didn't want people to manually paste things in text boxes and hope that somebody deployed something eventually. We wanted changes to go out relatively soon. So we built all those things and ultimately replaced this deployment system with something else. On the same topic of deployments, we also tried to push people more towards feature flags to medium success. I think this was something that was in progress when I was when I stopped working at Sentry, and like something that we had worked towards for years at this point. And I think there was some success by the end. Like the way feature flags used to work is you would specify a flag, and then you would ask SRE to edit the database to set that flag to a different value, which meant that you would often wait like days and days in order to update a flag. And so people just didn't do it. People would deploy code, and that meant it was live, instead of the feature flag workflow where you deploy code that's behind a disabled feature flag and then enable it at a time that you want it to be. The phrase that we would champion a lot is deployment is not go live. Go live is when I flip the flag to actually being true. And we helped build out a system where people could self-service feature flags, a set of YAML files in a repository that got mounted as a config map and updated the database in the same way that an SRE would, but instead of it being like order of days in order to update it, it might be order of minutes. And so you had a much more direct path to enabling feature flags. And a lot of this was the people side of this, evangelizing this idea and saying, hey, maybe we should instead lean on a feature flag to turn this thing on or off instead of a code deployment. I think ultimately it was a work in progress, and I wouldn't say it was completely successful, but moving towards that. Another thing that sort of falls into this deploys bucket was the SDK and library publishing. I sort of mentioned this earlier when talking about the non-technical accomplishments of team merging. This came from the foundation team, and largely is these two repos called Craft and Publish. This is kind of the way that library vetting and deployment happened at Sentry. And we did a few things to this, but largely took this over in a maintenance only mode. But we added a few things because this was also the system that got used for publishing internal libraries. And so like I built out an entire system for auto approving internal libraries. And so this janky GitHub Actions ternary expression is one of the ways that we auto promoted internal libraries at Sentry. But this whole system, we inherited this system, and it's a kind of wild set of manual checkboxing and GitHub labels. Oh, you can't even see the labels because I'm not a member of the org anymore. But that's how all SDKs got published and internal libraries got published. But that's deployments. And now we get to talk about my favorite bucket of things, which is other MISC shit. And a lot of this was passion projects, things that no one would have actually been responsible for, but things that I just took on because I felt like they were important. And one of those was upgrading things, major libraries, or the interpreter or other stuff. I'm going to talk just specifically about Python and Django, since I think those were the biggest and most impactful things. But when I joined, Sentry was on Python 3.8, and no one had upgraded for years because it was difficult to do so. There were a lot of moving parts that needed to go into making this possible, like manual versions changed on running hosts, like Sentry is not completely containerized, like making the development environment roll forward and roll back as the version changed. Like all of these things weren't in place. And so part of getting to things being just a feature branch, which this, upgrade to Python 3.10, this was just a feature branch. Nothing was really special about this, approved by Ian and deployed, and everything went smoothly. And it was really just changing the version numbers and updating the pre-built version of Python and refreezing the requirements, changing a little bit of version numbers here and there. And that was it. This was the dream, was getting a Python version upgrade to be just another feature branch. But not shown here is all of the work that went into making this possible. A lot of this was, making the developer tooling understand that, hey, if we have this version, it doesn't match the version we have, built an environment for, we need to update that. We need to make this be able to roll forward and roll back. We need to be able to run our CI against a different version of Python. Like, all of these things didn't exist and were things that I built out or the team built out over time in order to make upgrades, just another change. And not all things went smoothly though. 3.10 was one of the few it was one of the few Python upgrades that went off without a hitch. 3.9 and 3.13 were also ones that were very, very easy as well. 3.11 I think was by far the hardest one. You can see here that it took me 10 reverts in order to get this out. And actually I made a video specifically about why this was difficult and why a change in Python ended up causing a performance regression that basically melted our production pods. I also learned a new tool while building this. And again, this is another example of like, I did a really hard thing at work. I learned a really cool tool and I was able to share that knowledge and exactly the failures and what stuff I learned in a video that I can share with all of you. I think I remember that PySpy is actually dead now and there's another tool that replaces it, but that's a video for another day. But I think this was, just another cool example of like something I was able to build here. 3.12 also didn't go out smoothly either, and I learned, a bug in PyUSG, and I still think these title is, this thing here is not clickbait. Like, this is the most complicated bug that I've ever fixed, and I think this shows some really cool debugging processes. And yeah, it's an hour-long video. Like, this is one of the, like, I think this is one of the coolest things I've ever done. Like, full stop. Or maybe one of the hardest things. I think one of the coolest things I've ever done is probably some of the like image processing Pokemon stuff. But anyway, I'm really proud of this video. And this was something that like I was able to share all of my learnings with everyone because again, Sentry was open source. This was something that I worked on in public. This is a public library that I ended up changing and fixing. And I show all of the like bisection, GIL management, like weird thread state nonsense, and ultimately fix some undefined behavior in USG in order to fix this, which is kind of cool. But again, like this was some of the hard work that went into upgrading Python versions that ultimately was successful. I think what's also not really shown here is some of that work that I did before around warning clean stuff. There was a lot of work that went into this, and you can see like, well, maybe not this one, but oh, do I have the other one? Do I have the 3.10 one? Yeah. You can see here, for instance, like this branch got rebased many times. And each time I rebased it here, it was me taking some change set from this and splitting it out into some other pull request, whether that was upgrading a dependency or fixing a warning or fixing a test or other stuff like that. And so a lot of work actually went into this that isn't shown in this PR here. Sometimes I would do a little summary at the bottom, but I didn't bother with this one. But a lot of these change sets involved splitting out, like I said before, splitting out a bunch of small things in order to land the ultimate impact at the end. And you know, all of the investments that went into this ultimately made upgrading Python just another feature branch, which I think was really cool. In the same way of upgrading Python, I upgraded Django. I don't think I have a tab for this, maybe. Oh, I do have a tab for this. Do I have 2 tabs for this? No, only 1 tab for this. When I joined, Sentry was on Django 2.2, which at the time was actually end of life already. Or maybe it wasn't end of life yet, but it got to end of life at some point, and we needed security patch fixes for it. And so people were like scrambling to try and figure out like, how do we get to Django 3 or Django 4? I think Django 4.2 was out at that point, and we were just so far behind. and no one had really thought about trying to upgrade it. And I said, that sounds like a fun thing. I'll figure it out and make it happen. I think this patch actually has more of the context, or at least you can see this same rebase pattern of me splitting out patches here and getting it working, and ultimately taking all the other components and getting into a state that was working well. But this, again, a lot of work went into this, and I'm really proud of being able to, again, get this down to being just another feature branch. This one is, I think, a little bit more complicated than some of the newer upgrades, because Django 2 to 3 was a beast. A lot of breaking changes happened in Django 3, and anyway, but the patch ends up looking pretty similar. Like, it was just like, changing an argument here, removing an assertion here, adjusting this subclass here. I think I actually did a stream on this one too. This was a fun one to find and fix, and that they changed the default signing algorithm between two versions, which I think means that for a while things were just nonsense in emails, but whatever. That's intentionally changed in Django. You just have to find out that it's different if you didn't happen to have a test. Sentry was lucky that they had a test here, so that was kind of nice. But yeah, eventually got Sentry to use the latest version of Django, and had to deal with all several hundreds of breakages along the way. But again, this was the same process as upgrading Python. Upgrade the necessary ancillary dependencies, get CI passing, get warning clean, etc. Change the memcached library, change how it connects to databases, adjust all of the model setups, fix features that got removed, manage migrations for things that got removed. Lots of complicated work went into things like this, but ultimately get it down to just one simple pull request. Cool. On the same topic of miscellaneous changes, this one's a small one, but Sentry CLI, which is the tool that's used to upload symbols and other stuff, or to do instrumentation of Bash and other languages where you wouldn't have an SDK. This was originally only available through curl sh or through npm, and so I made it pip installable. This was actually really helpful for us in the development environment, because we used the Sentry CLI to look at how the development environment worked, because it used to be a bunch of shell scripts. It's not anymore, so I don't think it actually gets used there. But other people appreciated this too, apparently, because it gets downloaded a bunch. So I think that's kind of cool. And you can see that it's not just Sentry, because it's a whole mishmash of Python versions, and Sentry is the Python 3.13 one and not the other ones. So other people are using this, but this was a small change that I think had a pretty significant impact. Next, I'm not going to go into the details of this, but you can watch this other YouTube video. Again, this is another one where I solved a hard problem at work and managed to have a really cool impact, and could show it off in a YouTube video that I could share with everyone. But I actually made every Sentry page about 300 milliseconds faster. And this wasn't my intention. My actual intention was to be able to make the front-end code incrementally deployable, similar to what we talked about before with canary deployments. I was trying to enable canary deployments for front-end. And in order to do that, I needed to be able to address them statically instead of the dynamic way that they were being instrumented before. Anyway, long story short, small pull request that adjusted how asset hashing worked to make URLs deterministic and ultimately leverage the browser cache instead of having to do etag requests every time. But this was just a cool thing that came out of trying to do something else that I could also share the technical details with the world, which again, really cool. Next is Pickle. I've talked about Pickle a lot, not in videos, but in streams. Pickle, it is by far the worst serialization in Python, because it is essentially arbitrary code execution in a weird binary format. And it has all sorts of problems. One being that, well, it's arbitrary code execution. So if anyone controls a pickle, they can run any arbitrary code. But the bigger problem being that if you move any of your data structures around, you're just not going to be able to deserialize that data later. And so I decided to take on a project to eliminate pickle usage at Sentry in the data stores. because we used to store pickle blobs in the database. And this, again, security issues, but also it had different issues. Like the reason that I solved this was not the security issue. It wasn't the speed issue, because pickle tends to be slower than we ended up using JSON, or the size issue. Binary data in a database, not great. So JSON tends to pack a little bit better. But the actual reason that I took this on was for queryability, because you can't really query a binary blob, but you can query a JSON blob if you're using Postgres, which Sentry is. And so querying JSON and Postgres is a thing. And the data team wanted to be able to use this for particular fields that had been using pickles before. And so I worked out a whole migration pattern in order to first validate that this was even going to be possible. So I set up a little round trip validator in the little pickle field to say, like, hey, if we dump this to JSON and then load it back, is it the same? And set up a feature flag. This was before we had a good feature flagging system, so it was actually just a Django option, and a sampling rate in order to figure out whether this was a problem, and then ultimately log that to Sentry. So I could figure out, well, I could set it to true in tests, and I could log it in production without actually impacting the real site. Yeah, it might be a little bit slower because we're doing a little bit of extra work here, but it was something so I could check, like, if we flip this thing on, is it going to break the world? And then from this, I built a bunch of migrations to load all the data and then save it again as JSON, and ultimately moved all of Sentry's pickle blob data to being JSON blobs. But this was, again, one of those long tail projects where the actual validation was pretty straightforward, and this is Armin with an I who was also helping champion this project, because again, the people side of all of these things is always difficult. And so Armin was kind of the sponsor of like, hey, no, we shouldn't be storing pickles in the database. Let's get this fixed and done. But went through a bunch of changes, rolled this out without regressions, which I think was pretty wild. I mean, it did have some problems in the open source distributions just because of the sequencing of things, but ultimately was able to get this out. And this was just one part of it. It actually was like 100 change sets, because I went model by model to do them one at a time to reduce the impact of any of them that I broke. But yeah, ultimately this was successful, and I think this was like a really cool, I hate pickle, and so this was like one of those passion projects that I was really excited to work on and ultimately finish. Speaking of passion projects, if anyone's worked in Django before and worked with Django migrations, you'll know that you end up with thousands and thousands of migrations over time. And this has significant impact on a lot of parts of development. Setting up a development database means you have to run all the migrations. And so if you have hundreds or thousands of them, for whatever reason, Django is really poor at managing this graph. And so it's not actually a linear growth in time. It's something like quadratic as you add more and more of these. So it slows down, setting up a development environment. You sometimes run them for tests, so it slows down running tests. When you deploy, you should probably try and apply migrations, even if there aren't any, just so that your database in production is always up to date. And so applying even a no-op application of thousands of migrations takes, on the order of minutes. And so periodically in a Django app, you work to squash migrations. And Django has some tooling for squashing migrations, but it's not very good. Not only is it not very good, but sometimes it leaves behind changes that are done in particular ways, or if you have a manual SQL migration, that's not going to get captured in the squash migration. If you have a Python operation where maybe you need to do a data migration, you probably don't actually want that in your squash. You want to just assume people have already run it. But Django's thing will try and hoist it into there, and then you have invalid imports, and it doesn't work very well. So what I did is I built a tool for automatically squashing migrations, and it's complicated to get this in a way that's well done and works, and has something that you could automate and you could run repeatedly, and actually go about squashing migrations. The other thing that you have to worry about is detecting drift. Basically, you can do manual operations and migrations that aren't represented using the normal migration operations, or sometimes there's ways that you can accidentally break a migration. For instance, like changing a base class in a Django model. The migration system doesn't actually detect that by default. So you have to be careful about that. And so I had to basically find all of the drift and eliminate it before squashing migrations. Migrations had not been squashed for, I think, 2 years at this point, and it was adding like 15 to 20 minutes to every deployment just to do nothing. And so I went through, figured out all of the drift that had occurred over the last couple of years, and then eliminated all of it except for some of it. I did leave behind some of the drift because it just wasn't meaningful. Like this is an example, like scopes big int default 0 not null is actually completely equivalent to scopes big int not null in this particular database system because of the way the model was set up. The model itself had a default, and so these were the same. So I was fine leaving this particular thing behind. Same for like these indexes here. Like this was just like index ordering and stuff, and explain all that here. But anyway, eliminated all the drift that I could through a series of like 50 pull requests, built this tool for automatically squashing migrations, ran it, and then built a system to prevent drift going forward. That way we could enforce that we can, at some later date, re-squash migrations and successfully move on with our lives and reduce all of the Django nonsense there. But meat. I did eventually find that there was a cycle that made things flaky, fix that, blah, blah, blah. But there a whole bunch of work went into making this migration swasher. But it ultimately, small tool, big impact, kind of the theme here. And a lot of also small work in order to get this thing to land, because I had to do a bunch of schema fixing. Cool. And that brings us to the last thing that I wanted to talk about. And I think this is maybe the thing that I put the most effort into and the thing that I think I was the most passionate about. And I saved it for last for a bit of a special reason, which is the MyPy and type annotation setup at Sentry. And I know I know that typing is a controversial topic, and I mean, it shouldn't be a controversial topic, but ultimately was a controversial topic, especially at Sentry. Hello. It was also a popular choice at Sentry, but that's a whole different thing. Anyway, early on, well, relatively early on at Sentry, I reworked how the MyPy setup was set up at Sentry. The initial setup was not set up in a way that made incrementally adopting typing easy. It was basically an allow list of strict modules. And strict, I actually think strict in MyPy is really, really difficult to do. And I don't even use strict in my own repos. And so opting into strict in a subset of files made it really, really difficult to adopt. And it meant that people didn't do typing because it was a huge pain in the butt. And it didn't actually provide a lot of value because it didn't follow modules. So like you would have to put a bunch of ignores everywhere. And it wasn't set up well. So I switched it to a gradual typing, which I've talked about many times. I think I even have a video on gradual typing. And this is kind of the recommended way that people adopt MyPy. Start in a case where you're not requiring type annotations anywhere. You're just checking like module scope and making sure that those pass MyPy in the most basic mode. It ignores things without annotations. It just treats them all as any. And then you slowly add annotations to a code base. You incrementally adopt MyPy. We, of course, had to take an even more incremental adoption here, which is there were 20,000 ignored errors when we started because a lot of things were failure, or a lot of things were just mistyped or wrong, or things that the type system didn't understand, or magic or other stuff like that. And so I started by skipping nearly half of the code base, and that included about 20,000 errors. There was a allow list of files and eventually an allow list of codes. So you can see here, like, these are the 2,500 modules that were initially ignored. And yeah, I introduced this new way of incrementally adopting MyPy. And at first, this was just an incremental system to switch us from the thing that people weren't adopting to something that was easier for people to opt into and easier for people to fix particular problems in the code base and take ownership of their modules and enforce stronger, stronger type safety. This was also something that people continually pointed out in like incident review, where it was like, oh, yeah, if we had typing on this, obviously we would have caught this bug before production. Like we would have caught this without tests, and tests didn't catch this problem. So we would have caught this before production. And so I put the infrastructure in place to make this happen, and then went to TSCs and we're like, hey, we have this new tool. We've reworked how MyPy is set up. You can go ahead and adopt it in your modules if you want. This is like an easy way to improve the reliability and quality of your code such that you reduce problems that you have in production. And really just, run MyPy without ignores, collect all the errors, and create a block list. That's really all this tool did, and allowed us to rework how MyPy was set up. But that's not the full story here, because this patch itself is really small. It flips the block list and inverts it into a different way, and allows people to incrementally adopt typing. But the actual part where a lot of work went into was to try and systematically fix some of these 20,000 ignored errors, because 20,000 errors is overwhelming. No one could ever possibly stare at that and say, yeah, we'll fix those all someday. And unless there's a concerted effort to approach those, like, this is never going to happen, right? Right? Surely no one could possibly ever tackle 20,000 errors. And what actually happened is, once this thing was set up in place, obviously some of the first initial patches eliminated a lot of things. Like the first patch I did, like one line change fixed 12,000 errors. So 20,000, maybe a little bit exaggerating here, and maybe it's probably closer to about 10,000 errors, but I digress. By setting up this automatically ratcheting infrastructure and giving people the tools to fix things and giving people the tools to opt into stronger typing where they needed it, ultimately this block list was crushed over time. It was never actually finished, unfortunately. There's, I think, about 300 errors remaining, but over time this was pretty well reduced. And you can see this is actually a graph that one of my viewers made. I forgot, I should credit who they are. This one is from I'm going to do another video on this topic eventually too, so we'll have a big one. This one is from Particularly Pythonic. Actually, I think both of my graphs are from Particularly Pythonic, but a bunch of my other viewers also make graphs as well, and I'll be showing each of those in another separate video, because I think I'm bearing the lead about the lead a lot on this, on some of the data that I had here and some other really cool things that I managed to find from this data, as well as the process I used to generate this data, because that can be a whole separate video. But and ultimately I fixed most of the errors. Of the, I think it was, let's see, what was the number here? 22,163 errors. Of those, I fixed 20,319. So overall, yeah, I would often, in meetings or when I had downtime or while I was waiting on builds, I would just fix MyPy errors, and slowly, incrementally over time, a lot of, I mean, I don't want to say all of it, but a lot of the downtime here was stuff that I put in because I wanted to see the errors go away, and I wanted to enable developers to enforce better, stronger typing on their particular modules, and just make things better over time. Yeah. And along the way, I also spent a lot of time contributing to the Django types. So this is Django stubs in the type Django project. There's also Django REST framework stubs, which is another thing I contributed to. But I cracked the top 10 of things that I improved here. And actually, if you're working in Django and you want to make, you want to move typing forward, this is a great opportunity to do it, because a lot of these stubs are really incomplete. And it's really just, run MyPy with this plugin and fix stuff. And I managed to make a lot of improvements here, and I think like the Django community as a whole benefited a lot if they're using this thing, because I made it a lot better from stuff that I wanted for work at Sentry. So I made that happen. I also built a lot of cool infrastructure, in addition to working on typing stuff, and some of it I open sourced as Sentry. For instance, this really cool tool that I made a video on, not that one, called Auto Type Annotate. Which just automatically adds annotations, which I think was really cool. Like uses dmypy and some cool stuff in order to auto annotate stuff. But like this was a really cool tool that I built, on stream, and was able to make a cool video about it. But yeah, you can search my channel for this as well. But yeah, I guess I won't be working on this anymore, but it was fun when I built it. Oh, okay. So we've gotten through technical accomplishments, or at least some of them. There's so many more things that I don't have time to talk about, and I feel like I've already exhausted the time that I wanted to talk about because we're 90 minutes into this video. So let's talk about what happened. But before we talk about what happened, I do want to talk about one thing first, which is I want to talk about remote work. And I've talked about this a little bit before. Remote software engineering, my strategies for making it work. And for those that don't know, Sentry is based in a couple of offices around the world: San Francisco, Toronto, Vienna. I think there's one a satellite office in New York. I think there's a satellite office in Seattle. I hope I'm not forgetting any of them, but I'm in Michigan. I'm not in any of those. I'm not in an office. I was hired remote, and I was hired in a time where remote was much more common at Sentry. 2020 sort of necessarily forced remote on the entire industry. Some adapted, others just sort of skirted by. And I also think the remote work is pretty difficult to get right, especially when a company traditionally was based out of an office or, returned to office. As the pandemic ended, many companies forced return to office on employees. Sentry was one of them. I was not obviously exempted from it because I was hired explicitly as a remote worker. But many others weren't. They were forced to come into the office. And I, working remotely when no one else is working remotely is difficult. And I tried my best to try and make things work, although I think ultimately there's just a mismatch there. But I could name a laundry list of things of why I think Sentry didn't do remote work well. But I'm going to give you two small anecdotes that I think outline some things that go, or at least explain to me why I knew this was going to be a problem and ultimately didn't get solved. And the first is actually from my first week at Sentry. I joined, bright-eyed, happy, and like ready to work on this cool company that I'm really excited to work at. And Sentry has like a cool culture around like they have a weekly happy hour and like games and other cool stuff if you're in person. And so when I joined, I got the company calendar and I saw that there was a happy hour calendar invite. I'm like, cool, great, awesome. Maybe. I had worked at Stripe, which had tried to make this work a little bit. I guess Stripe didn't really have happy hours, but they tried to make social events actually happen for remote employees. So I was like, oh, cool. Sentry is doing the same thing. And I can, dial into this happy hour and have a great time and, enjoy company culture, even though I'm remote. And so, I first dialed into the Toronto happy hour, which is in the same time zone as me. And I went down to my fridge, grabbed a nice beer mug, poured my nice beer, all ready to dial into this meeting. And I clicked join meeting, and it's just me. And I'm like, oh, maybe they just haven't set up the camera yet. I'll just wait for the meeting to start. And I sat there, and 3 minutes went by, and I'm like, maybe this isn't gonna start. 10 minutes go by, and I give up on the meeting. I'm like, damn. Okay, maybe the Toronto office doesn't do it. Maybe it's just an SF thing. I'll wait for the SF happy hour, which is 7 p.m. my time or 7:30 my time, and I'm like, okay, great. All right, I guess I got to drink this beer. I'll wait 3 hours and then dial into the next one. And so I repeat the same process. 3 hours later, I dial into this meeting. I didn't pour the beer yet because I learned from the last time maybe this isn't going to be a thing. And I wait for 10 minutes again, and no one shows up. The meeting's never dialed into, and I never really, except when I visited the office, I never really experienced a happy hour while remote, which is kind of a little sad. But I understand it at the same time. Even if, could have done a small thing. And this was something that I suggested repeatedly. It was like, hey, you want remote employees to feel included? Just dial in the fucking camera in the all hands space. Even if no one's there, I can feel like I'm hanging out. I can feel like I'm part of the culture. And then I want to talk about another anecdote, which is the RTO policy. And even though I wasn't affected by it, I couldn't help but notice some things that felt wrong to me, and I was purely a remote employee, so I'm a fly on the wall, and I'm there to just laugh at the memes and wasn't actually directly affected by it. But Sentry's RTO policy, I think, dictated that there were 3 days in the week where people were supposed to be in the office, and the entire claim of return to office is that engineers are more effective when they're co-located in an office. When they come into an office, they're more productive. They're going to get more shit done. And I could never really look at the RTO policy and be like, they're only requiring 3 days a week. So they're basically self-reporting that they don't care about engineering productivity on 2 of the 5 days a week. Suspicious, right? But I think I get why it was done. I also understand why it was done. It's not that I think I get why it was done. I understand why it was done. Because if they went to straight 5 days a week, everyone would quit. But anyway, even though my Sentry didn't do a lot to try and make remote work well, my team did put in a lot of effort to try and make remote work successful. And some of the things that I did, I outlined in this video, but I want to just call out 2 things that I think went really, really well. One is that my teammates and I set up weekly one-on-ones just so that we were checking in on each other, and might not even be about work. A lot of them were about work, what you're working on, what things aren't working well, complain about this person, complain about that person, etc. It was a safe space to just have a social aspect. Sometimes it was just, we would talk about running or pizza or video games or whatever the heck we wanted to, but it was a space to have face-to-face contact in something that felt like you're connected with your employees. It's something that remote work can be pretty lonely, and without that, it would have been a lot harder. Another thing that we did is we organized a weekly games hour. On Friday, we would just have we pick a online game that we would play together, and a lot of times it was just code names or Pictionary or things like that, things that were easy for us to, or Scriblio, not Pictionary, that's the one in person. Scriblio, I think it's called Scriblio. Anyway, it was just something for us to hang out, work together, realize that the manager of my team sucked at drawing, and some people were just mind meld and knew exactly what you were drawing before you. It was a lot of fun, and it was something that felt like I had a real connection with my teammates, and actually made it feel like I belonged. But yeah, remote work's hard. But that's okay. I'm off topic. What actually happened? I ultimately cannot get into the specifics. But I will tell you what I think I can tell you, which is that I stuck to my principles. I pushed for what I knew what was best, or I pushed for what I felt was best for Sentry. And sometimes pushing hard for what you believe in can ultimately undermine the effort entirely. I think that's probably the nicest way to say that. And I know this isn't the spicy or satisfactory answer, or the real details or whatever. But sometimes you just have to let the chest speak for itself. Okay, so what's next? Now that I'm not at Sentry, what am I working on next? Um, I am going to be taking time for myself to do things that I want to do for at least the foreseeable future. But there are two things that I'm really excited to spend some more time working on because I feel like I haven't had the time to work on them in a while. And one of them, of course, is pre-commit CI. If you remember 2020, this is also what I did last time I was unemployed. I spent 9 months building pre-commit CI from scratch, and I wouldn't say it's been completely in maintenance mode, but I haven't been able to devote a good chunk of time to actually work on development for this. There's a couple of things that I think are really important that I haven't had time to work on. One of them is self-service invoicing, because right now there's some weird GitHub customers that should be paying me but aren't because I have to manually bug them, and that's a pain. I also want to work on other platforms, especially GitLab, and maybe validating commit messages and some other ideas that I have that I just haven't had time to work on. Maybe code coverage, I don't know. Finish cov.ci that I haven't done in a while. And the other thing I want to talk about, which I'm actually really excited about, is I'm a University of Michigan employee again. I'm going to be working on this project called Joseki, which is a funky, it's an AI programming language, but if you know anything about my channel, I'm not really a proponent of AI. But I think this is a really cool opportunity. Basically, a couple of professors got an NSF grant to work on, what do they call it? Open source sustainability, basically community building around a project, developer advocacy, contributor quality, governance, like basically trying to make a successful open source project and show that it is sustainable from a contributor perspective, from a funding perspective, and actually grow a tool. And despite all of the buzz around this particular thing is, or I mean, the most significant buzz around this particular thing is the LLM integration, I actually think this has some really cool features and can potentially be a cool project that needs a lot of help to get to a place where it's easy to develop on, it's easy to understand the documentation, it's easy to use. And I think I have some unique opportunity, or like some unique knowledge in building open source projects to help them, and get paid to do it. The other cool thing, or the other thing that I think I can potentially get out of this is I really like teaching. It's why I make YouTube videos. It's why I like explaining all of these things. It's why I'm passionate about sharing my experiences and the stuff that I learn, and like, why doesn't self work here? Like, it's why I'm passionate about doing all this. It's why I'm making this stupid video in the first place. And I think there's a real opportunity for me to end up in a teaching position at the university, and maybe being able to leverage some of the work that I do here to build something like that. I also think that there's a huge gap. There's a massive gap in knowledge around not just software engineering, but tooling and like a lot of the stuff that I preach and show on stream, like how to manage a GitHub repo, what to deal with commit messages, how to set up CI, all of these things that you don't learn in school because you're too focused on algorithms and data structures and random C++ behavior, when like people actually need to be able to do work and exist in a society and do development work. And I think there's an opportunity to make a course that is better about that, like how to work with GitHub. Like, I was never taught that. I trial by fire, that's how I figured it out. My commit messages from 2009 were garbage. I didn't know what I was doing. Fix 40 commit PR that, oh, it got squashed, I didn't have to worry about it. Like, the things you just don't learn in school. And I think there's an opportunity to fill some of those gaps and like use some real industry experience to help people learn better. I also secretly have a little selfish thing, which is the two professors that are working on this are compilers professors. And I have written so many really bad parsers and compilers, and I want to learn properly. And so I might actually be able to take a compilers course. It's one of the few courses that I wish I would have taken when I was in school that I did not have a chance to do. So I might be able to do that. And I think there's also a cool opportunity there. Like, I take a course at a university, I can make content that's basically my version of that course and share that with all of you as well. And I think that's a cool opportunity. But anyway, yes, AI programming language, blah, blah, blah. But I think there's some other really cool things that might come out of this. And so that's why I'm excited to work on this project. And my God, there's a lot to fix. And so there will be a lot of YouTube videos about stuff that I find that can be improved in this project from like a developer and contributor standpoint. I hope you're looking forward to maybe not content directly about this, but things about development processes and maybe some content about this at some point, because I think there's actually some unique paradigms that have been introduced by this programming language. But anyway, that's what's next. I'm so sorry that this video is so long, and there's so much more that I wish I could have showed you and talked about. But even at hour and 50 minutes, I feel like I've talked my head off for too long. And I hope you enjoyed this, and I will see you around.